Yes, the problem is from GATE 2019 mathematics paper, question number 46. The problem is, let V be the vector space of all 3 cross 3 matrices with complex entries over the real field. Here the field is important. It is real field. And if W1 equal to the subspace given as the set of all matrices A in V such that A equal to A conjugate whole transpose. That means the W1 is nothing but the subspace of all Hermitian matrices, and W2 equal to the set of all matrices A in V such that trace of A equal to 0. Then the dimension of W1 plus W2 is equal to dash. Here it is given that A conjugate whole transpose denotes the conjugate transpose of A, which means we have to conjugate each element of the matrix A, then we have to do the transpose to the whole matrix. That is the A conjugate whole transpose. And the references, the NPTEL reference to solve this problem is a lecture by K.C. Sivakumar of linear algebra, and he is from Department of Mathematics, IIT Madras. The lecture is lecture number 12 from module 3, and the title of the lecture is Dimension of a Vector Space. And the YouTube link to watch this lecture is this one. Now, from the given problem, we can see the sum of useful data as V, the given vector space, as vector space of all 3 cross 3 matrices with complex entries over real field. And the two subspaces given are as W1 equal to the subspace A belongs to V such that A equal to A conjugate transpose, and W2 equal to A belongs to V such that trace of A equal to 0. Now coming to the solution, it is asked to calculate dimension of W1 plus W2, but the given conditions are given data is the subspaces W1 and W2 only. So to calculate dimension of W1 plus W2, we use a formula, that is dimension of W1 plus W2 equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Since W1 is given, we can calculate the dimension of W1, and similarly we can calculate the dimension of W2. But to calculate dimension of W1 intersection W2, we would have to do some calculations that we will see now. Now, for any matrix A in W1, we write A as Aij, where Aij is written as Aij plus I times Bij, comma 1 less than and whereas Aij and Bij's Aij, Bij are real numbers for 1 less than or equal to I, j less than or equal to 3. That means the matrix A is written as 3 cross 3 form with the entries as Aij plus I times Bij, since the matrix is with complex entries. Then by the given condition we have, then since we have A is in W1, so we have A equal to A conjugate whole transpose. So by rewriting the matrix A and A conjugate, that is A equal to Aij whereas A conjugate whole transpose is A J I whole power. Since by the given condition we get A equal to this one, the usual matrix we considered, and A conjugate whole transpose is this one. For so then by equating these two matrices we get by equating A and A conjugate whole transpose we get Aij plus I times Bij equal to Aji plus I times minus I times Bji for all 1 less than or equal to I comma j less than or equal to 3. So from this we can observe that Aij, from this we can observe that Aij equal to Aji and we can observe that Aij equal to Aji and Bij equal to minus Bji for all 1 less than or equal to I comma j less than or equal to 3. So we can see that in fact for I equal to j we have Aii equal to Aii, but Bii equal to minus Bii, which is possible only when Bii equal to 0. So we can write the matrix A as the 3 cross 3 matrix as A11 A12 plus IB12 A13 plus IB13 and A since A21 is nothing but A12, I'm writing A12 minus, since B12 is minus B21, so I can write this as IB12 A22 and here A23 plus IB23, and the third row becomes A13 minus IB13 A23 minus IB23 and A33. This is the matrix A, where Aij, Aj, comma, okay, Aij, comma, Aii, comma, Bij are real numbers for corresponding I and j. So we can see that the matrix A, in the matrix A, the number of independent entries are 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 9 entries which with which we can form the matrix A. So from this we can say any matrix for any matrix A in W1 will be generated by the matrices 1 0 0 0 1 0 sorry 0 0 0 0 0 0 comma 0 1 0 0 0 0 0 0 0 0 0 1 0 0 1 Here we get 1. And here in the matrix 0, 1, 0, 0 up to 0, 0, 0, 0, 0, 0, 0, 0, 1. And these are 1, 2, 3, 4, 5, 6. 6 in number. And the remaining matrices are 0, I, 0, 0, 0, 0, sorry, here minus sign, 0, 0, 0, comma, 0, 0, I, 0, 0, 0, I, 0, 0. And the last matrix is 0, 0, 0, 0, 0, I. Here we get minus sign, 0, minus sign, 0. These are the 9 matrices which generate W1. So we can say dimension of W1 equal to 9. This is over the real field. Over real field. And now coming to the subspace W2. Now for any A in W2, we have trace of A equal to 0. That means when we write, let's write A equal to that matrix Aij, where Aij equal to Aij plus Bij, I times Bij, where Aij, Bij are real numbers for 1 less than or equal to I, j less than or equal to 3. Since trace of A equal to 0, and we know that trace of A is nothing but the sum of the entries of in diagonal of A, that is A11 plus IB11 plus A22 plus IB22 plus A33 plus IB33 equal to 0. That implies we get A11 plus A22 plus A33 equal to 0, and B11 plus B22 plus B33 equal to 0, since the field is real. So we get A11 in terms of A22 and A3, and similarly B11 equal to in terms of B22 and B3. So we can write the matrix A as, so A is nothing but minus A22 minus A33 minus I times B22 minus I times B33, and the second entry as A12 plus IB12, A13 plus IB13, A21 plus IB21, A22 plus IB22, A23 plus IB23. The third row is A31 plus IB31, A33 plus, sorry, A32 plus IB32, A33 plus IB3. From this, we can see the number of unknown scalars in this matrix are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are counted 12, 13, 14, 15, 16. and these two are also counted. So the number of unknowns in this matrix are 16, which is nothing but the dimension of W2, since A is taken in W2 subspace. This 16 can be, and here we can see the all the generators of W2. That means the 16 matrices. We can see that as in the as we are done in the case of W1. And to calculate the dimension of W1 plus W2, we are still remain with the to calculate the value of dimension of W1 intersection W2. Similarly, as W1 and W2, we consider a matrix. Now we consider a matrix. We consider a matrix A in W1 intersection W2. Okay, let me write here a statement as y dimension of W2 equal to 16. Since there are 16 unknown scalars in the matrix A, so dimension of W2 equal to 16. So now we consider the matrix A in W1 intersection W2. Then we have A equal to A conjugate transpose and trace of A equal to 0 also. From the calculation we did for the subspace W1, we have seen that any matrix in W1 should be of this form. And in addition, the trace of this matrix should be 0. That means, let me name this matrix as 1 or star. From star matrix, we have A11 plus A22 plus A33 equal to 0. That means, it implies A11 equal to minus A22 minus A33. So we get the matrix A as minus A22 minus A33 and A21 plus IB21, sorry, A12 and B12, A313 plus IB13. Second row is A12 minus IB12. This is A22. This is A23 plus IB23. And the third row is A13 minus IB13. This is A23 minus IB23. Here A3. Similarly, we can check the number of unknowns here as 1, 2, 3, 4, 5, 6, 7, 8. This is nothing but the dimension of the subspace W1 intersection W. The number of unknown scalars in the matrix A or 8. That is the dimension of W1 intersection W2 equal to 8. So we are done with the dimension of W1 and dimension of W2 and dimension of W1 intersection W2. So now to calculate the dimension of W1 plus W2 by the known formula, we have it is nothing but dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2, which is nothing but 9 plus 16 minus 8, which is nothing but 17. That is the dimension of W1 plus W2. So the answer is 70. Thank you.